see that, it's asking if x equals 3, is it continuous or differentiable or whatever. So I know we need a flashcard on continuous and differentiable. And I know continuous, the limit from the left has to equal the value of f equals 3. And then it also has to equal the limit from the right.
So you should immediately write this down. Like, don't just leave it in your head, write it down. Perfect. Now what?
Okay, and then I think, I can't really remember, but so I need to study my flashcards to look better, but is differentiable pretty much the same thing, but just with f prime?
It's exactly the same thing except with that prime.
Okay. So,
But the other thing you do have to remember is, this is the way I've seen them trick you into the wrong answer. If this is not true, there's no reason to check the other. So I've seen a problem where if you check the other first, you actually get the wrong answer because you forgot to check this. Like if this doesn't work, you don't even check the other. It has to be continuous first.
okay.
So we want to check this.
Okay, so you start with finding the limit from the left. So you're going to use the x squared because it's less than 3. So that's going to be 9. And then for that one, you use the second 6x minus 9, and that's going to be 9. And then the last one is going to be 9.
So the conclusion is?
It's continuous.
Function is continuous at x equal 3. Just keep pushing yourself to always be really precise. The more precise, the fewer mistakes you'll make. So f is continuous at x equal 3.
Okay, so now we're going to check if it's differentiable.
Not it, but if f
Oh,
is
sorry, the function.
Not the function, that's just crap. Yeah, crap's bad too. Yeah, the word function, the word f, the word graph, they're all generic. No generic, specific. We want to check and see if f is differentiable.
Okay.
So what do I write?
Okay, so the limit of f prime of x as x approaches 3 from the left, so 3 minus, equals f prime of 3 equals the limit of f prime of x as x approaches 3 plus.
Good work.
Okay.
Going.
Finding the left and right limit of f prime, that helps you figure out if it's differentiable.
The reason why is this. If a function's continuous, what are the only two, like a function's continuous at x equal 3, what are the only two ways the function could not be differentiable at x equal 3?
Vertical tangent.
Vertical tangent and
Removable, not a jump.
corner.
Oh, corner.
Vertical tangent and corner. So if f happens to have a vertical tangent
Oh, it's going to have a 0.
at x equal 3, you're going to find a slope that's unknown. Like it's
Is it
straight up and
vertical?
down. Vertical.
And then if you have a corner, you can't find a slope there, so it's going to be
If f has a corner at x equal 3, what you'll discover is the slope on one side
It's different than
is different than the slope on the other side. That's why we're checking. So what does the symbol f prime mean?
the slopes on that.
Slope of f. So this is finding a slope on f. Where is this finding a slope on f?
Left of 3.
Left of 3. What is this doing?
Right of 3.
Finding a slope on f right of 3. If those two slopes aren't the same, you have a corner.
Okay.
So that's why we're doing this.
Okay, that makes more sense.
Wait, if they're the same, there's corner? Or if they're
They're different, there's a corner.
Okay.
Because a corner means the
Because you have
slope on
one positive, one negative slope.
slope on one side is different than the slope on the other. It doesn't have to be positive and negative. You can have corners that look like this,
But the slope
but they're
changes.
different. The slope changes. We want the slope to be infinitesimally close to being the same. So, that'd be good. So now what?
Okay, so this is where it kind of got stuck. I think, do you take the derivative of x squared and the derivative of 6x minus 9?
You do, but you want to make, I want you to be, so this is one of those ideas that to me is so common sense that if we'll just talk about it to the point that you also feel like it's common sense, you'll never forget. Because common sense things we don't forget, we just know, right? Like here's an example. Do you have to think very hard? Like if I say, how do I say this? Like on a graph, if you go up, would you consider that going in a positive or negative direction? Did you have to think about it or did you just know it? Just know it. That's how I want you to feel about this piecewise deal. So, if you have a formula that says this, what are you supposed to think when you see a formula like that?
Find all the x's and y's on F.
This is how we find every XY pair on F. Every one of them. So, all of you, tell me what's different between this and this.
It's broken up.
It's just broken up. There's just, and how is it broken up?
It's broken up. It has like a line that has a certain slope and it looks a certain way till 3.
Yeah, the key idea is 3 is the division.
And there's another
There's one formula over here, there's one formula over here. Pretty good? There's nothing more magical about a piecewise than that. Okay, if I take this formula and I do this, somebody besides Amanda, because she's doing really well, what have I created?
A formula to find all the tangent slopes of it.
Right. So this was to find all the XY pairs. If I differentiate that formula, I found one to find every tangent slope of each of those XY pairs. So how do I take a derivative of this? Amanda, no. Look. Cassidy, sorry.
Thank you. Don't you just find the derivative of both of them?
Right,
So-
because again, there's no difference really. You know, here I have one formula for all the x's. But now I just have 2 formulas, so I take the derivative of both.
Do
Does
you
that make sense?
equal them to each other since they're supposed to be? Or
So this, I'm going to say something very cynical. I have never said ever set these equal to each other. Like there's these nasty people out in the hall that keep telling you all that. Because I keep hearing students saying, like, well, don't you set those equal? Like, where are you learning this? Like, you guys all having little meetings on the side. Like, forget what Mr. Smith says. This is the better way. We can break away from our own calculus class. It's fine, go for it. No, I don't make those equal. But we do want to find the derivative. So what is the derivative? Like what? Like again, be the classic, writing the right things, not just saying, what do I write?
you do f prime of x equals, and then the bracket, whatever that's called, and then do 2x, comma, at x is less than 3, and then 6 at x is greater than or equal to 2.
Well done. You know, there's one little thing here that you have to kind of just memorize. When you're taking the derivative of a piecewise function, there's always the possibility that there's a corner. And until you verify that there isn't a corner, don't put the equal sign. So you have to wait until you verify that there's no corner before you put the equal. So just stop here. If that's the derivative. So what do you think when you see this? Ken, come on. What are you thinking when you see this? You want to go, please.
Both of the x's and then those will be the same. So you're really on the corner.
Not sure about that. What I was hoping you would say is, oh, this is just your formula for finding all the slopes about. No, what do you?
Hold on.
That too. So now what do we do?
Now do you plug in, like about, I'm trying to be precise, but like 3 and 3 from the left?
Close to 3.
Yeah, close to 3.
So what's the value of this limit?
6.
Skip that one. What's the value of this limit?
6.
So that just told you there is no corner. Because the slope on the left of 3 and the slope on the right are the same, so that's okay. So it is both.
Wait, how did we know that f of 3? Oh wait, you can just plug in.
Yeah, now I'm okay to do that.
Oh.
Jack, you need